Like in the first part of this question, we work out the position of the Saturn and the Jupiter after 5 years. So what we did, like example, in case of a Saturn, as it is for 30 years, 360 degrees. So in 5 years, it will be X degrees. When we work out, X was 60. So 60 degrees will be somewhat here. So that's the position of the Saturn after 5 years. Then
The
we
other
work
one
out what?
the other one will be 150 degrees.
Yeah. Then the Jupiter, as we did, it take 12 years for a one complete revolution, and we want in 5 years, so it will be X. So when we work out, it was 150. So 150 was somewhat, because this will be 180. This 90 with a measurement, it should be done. This 270, this 360 or 0. So 150 will be somewhat here. So the Jupiter will be here, J1. Now, the next part, they ask the position after 20 years. So same way we'll do, like for a Saturn, 360 degree or one complete revolution in 30 years. That's the orbital duration. But in 20 years, it will be X. When we cross multiply, we got 240. So 240 will be somewhat here. So this is a new position of the Saturn. We call S2. Now for Jupiter, if we want to work out for 12 years, like in 12 years, it complete one revolution. So in 20 years, it will be X revolution. So when we cross multiply, it will be 20 into 360, 20 into 360 divided by 12. So this will be 3. So this will be 600.
100 degrees.
600 degrees. 600 degree means like it will complete one revolution and it will start another. So because maximum
240
angle,
after.
yeah. So it will be once it completes its one revolution, it will, because in one revolution it complete 360. And then extra how much it will cover? So 600 minus 360 if we do, to know how much angle more. So again it will be 240. So the position of
Same
the
as
set,
S2.
the position of the Saturn will be J2, like here, like in the same line as S2. So if we observe from the Earth, what we'll see that the Saturn and Jupiter are aligned after 20 years. Is it clear? Why we subtract 300? Because one complete revolution means 360 degrees. So if we have angle more than 360, it means it is now again repeating the motion. That's why we subtracted 360. So it completed one revolution and it started the second revolution and cover about 240 degrees of the second revolution as well. Is it clear, this one?
Yes, sir.
So whenever you want the position of the planets, duration, always use this method to work out. Then state what is observed on the Earth after 20 years. So after 20 years, we'll observe Jupiter and Saturn are aligned. Choose two words from the list to describe each planet. Jupiter. So Jupiter is what? Gaseous and large. And Earth is what? Rocky and small. The average distance of the Jupiter is much less than that of Earth. The gravitational field strength at the surface of the Jupiter is greater than that of Earth. Explain how these differences in the densities and the gravitational field strength are consistent. Like how a density and a gravity here are related to each other. So, so average density of a Jupiter is much less than that of Earth. Like when we compare the density of a Jupiter, the density of a Jupiter is small as compared to density of the Earth. But the gravitational field strength is greater. So why the gravitational field strength is greater? Because Why density of a Jupiter is low? Because Jupiter is having,
Yes.
gas. Jupiter is having the gas particles. It's a gas giant, so it has low density
Then rocks.
because it is mainly composed of gases. Because mostly gases are there as compared to Earth, which is like solid or rocks are there mainly. But why the gravitational field strength is more? The gravitational field strength depends on the mass. So it has more particles or more mass as compared to that of Earth. Because it has a larger size. So as the loop, Jupiter is having a larger size, so density is mass over volume. Density is into volume is mass. So even though the density is less, but the volume is too big, so as a result, what will happen? The mass of a Jupiter is greater than the mass of Earth. That's why it has a stronger gravity. So gravitational field strength depends on the mass, where density depends on the type of the material, gas, solid, liquid. Gas has a low density than liquid, and a liquid has low density than solid. Is it clear, this one?
Yes, sir.
The average density of the Jupiter is 1300 kilogram per meter cube, and the volume is 1.4 exponent 15 kilometer. So we have to convert into meter meter cube, kilometer cube into meter cube. Look, if you want to convert kilometer into meter, what you do? Kilometer to meter for conversion, what we do?
Multiply by 1000.
Multiply by 1000. But this is a kilometer cube. So if we want to convert the kilometer cube into meter cube, we have to multiply by 1000 cube. Like same thing, if it was a kilometer square, if it was area, kilometer square into meter square, kilometer to meter, we multiply by 1000. But kilometer square to meter square, we multiply by 1000 square. So what we will do? We'll multiply this by 1000 cube. So this will become 1.4 into 1000 cube means like 1000.
9 zeros.
Yeah, 9 zeros are there. So it means 10 power 15 plus 9. So it will make 10 power 24 meter cube. This will become meter cube because the mass was kilogram per meter cube. So the volume must be in meter cube. Now to get the mass, density is mass over volume. So if we need the mass, density into volume will be the mass. Density is 1300.
1.82 into 10 power 27.
Yeah, so it will be a very large number. 1.82 into 10 power 27.
Kilograms?
Yeah, kg. Because the mass is in kg. So unit conversion is always important. If the volume is given in meter cube, we should have the volume. If the density is given in kilogram per meter cube, the volume must be in meter cube. If density was gram per centimeter cube, volume must be in centimeter cube. The next question, show that 1 light year is 9.5 exponent 15 meter. So we have the formula that speed is distance divided by time. Light year is a unit of a distance. So if we need the distance, distance will be speed multiplied by time. Light year is actually a distance traveled by light in 1 year. That is called a light year. So what is the speed of a light in a vacuum? You have to memorize this value, which is a 3 into 10 power 8. What about the time? Because it's a distance traveled by light in 1 year. So the time in 1 year, we have how many days? We have 365 days. So because this 3 exponent 8 meter per second, so time must be in second. So 365 days. 365 days, we convert into hours, we multiply by 24. Then these hours we convert into minutes multiplied by 60. Then minutes we convert into second, we multiply by 60 again. So when we multiply all of them, we will get the approximately same answer as 9.5 exponent 15. State one measurement that is taken when the determining the speed of which the galaxy is moving. So whenever we want the speed of the galaxy, what we have to measure? We have to measure a redshift, or you can also say a change in the wavelength. So how much the wavelength changes, using that we can work out the speed at which the galaxy is moving. Write down equation which relate the speed and the distance of the galaxy. So we have V equals h dot d. State how the distance d of far galaxy can be determined other than this equation. So what we can do, that was also multiple choice question, that how we can determine the distance of these galaxies by using the brightness of the supernova. The supernova is an explosion which happen for the high mass stars. When they turn from red giant, explosion happens, supernova, which leads to release enormous amount of energy and light energy actually. And we can use that to determine how far this happened or the distance of the galaxy from the Earth. Question 24. It is summer in the northern hemisphere in June. Which statement? So in the month of the June, the northern hemisphere is experiencing a summer. Which statement explain why? So what is the reason why the northern
D.
hemisphere? Yeah, good. So why the Earth is closer? No, if Earth was closer, then the temperature rise for both hemisphere, not only for northern. Earth spin axis opposite direction. No, that's wrong. The moon is full. That's also not the statement explaining. The North Pole is tilted towards the sun. That's why the northern hemisphere receive more energy than the southern hemisphere. So it will experience the June, the month of in sorry, it will experience the summer in the month of June. Which statement about the sun is correct? So when we talk about the sun is a dwarf star. No, it's a giant star. No, it's a medium-sized star which mostly consists of hydrogen and helium. Sun is not a very small star, or it's not a very big star. It is a medium-sized star which mainly contain hydrogen and helium. In question 26, the table lists some information about the stars. Which star will eventually explode as a supernova? So how to identify which will explode as a supernova? You have to identify the class of the star. So red giant, no, red giant will not be a supernova. Red giant will turn into a like planetary nebula, which eventually turn into a white dwarf. A neutron star is like a white dwarf is there. It's also like a low mass star. So the red supergiant will explode as a supernova. In question 27, the time for the Earth to orbit the Sun is approximately 365 days. The average radius of the Earth orbit is 1.5 exponent 8. What is the average orbital speed? But all the speeds are in meter per second. We have to convert kilometer into meter first. So we multiply by 1000. So this will become 1.5 into 10 to the power 11 meters. And the time, because the speed is given in meter per second, so the time must be in second. So we have to convert these 365 days into hours, into minutes, into seconds. And to get the average orbital speed, it is 2 pi r divided by t. So 2 multiplied by 3.14 multiplied by radius, which is 1.5 into 10 to the power 11 meter. And the time is 365 into 24 into 60 into 60. Because we need all the options are in meter per second, so time must be in second. and the speed must be in, the distance must be in meter. So it will be about 3 exponent 4 meter per second. The sun transfer energy to the earth through electromagnetic radiation, which what are the two parts of electromagnetic spectrum most of the energy belongs to? Like what are the main radiations which the sun is giving us? Main type of radiation. So mainly what sun is giving us, it is giving us the light and the heat. So the light energy and visible light it's giving us, and the heat radiation or infrared radiation. That's why B is the right answer. How does the sun produce its energy? So it's not by fission, it's by the fusion, and it's fusion of
D.
what? Yeah, so it's a D, by the low mass star, because the low mass star undergo hydrogen fusion. The diagram shows a star and its initial arrangement of 3 planets. As you can see, X, Y, and Z, they are all in line. Each planet orbit clockwise in a circle. The time for one orbit of Y is 3 times the time for one orbit of X, and time for one orbit of Z is twice the time for one orbit of Y. Starting from the initial arrangement, which diagram shows a position after X made one complete revolution? Like X has completed its one revolution. So if X completed its one revolution, X will be on the same position. So all of them, X is at the same position. And they said the time of one orbit of Y is 3 times the orbit of X. So means like the time for Y is 3 times for X. Or we can also say just because time for one orbit of Y is 3 times. So time for one orbit of Y is 3 times the orbit of X. That is what is written. The time for one orbit of Y is 3 times taken for X. So if we need the position, so it means like it is taking much longer time. So as it is taking much longer time, it means like the time for one orbit of Y is 3 times the taken for one orbit of X. So time taken by Y is 3 times, or we can also say like it will, the position it will cover, it will be 1/3. Like it will cover less distance. And so it will start to move, but it will take, like if X completed in say 3 days, example, if X completed in 3 days, this will complete, Y will complete the orbit in 9 days. So what will the position of the Y? The position of the Y will be like 1/3 of X. If the X completed one orbit, so this will be 1/3 of X, one third position it will cover. So 1/3 of the orbit, it will be somewhat here. So either A can be an answer or B can be an answer. Cannot be C, because C shows that it covered more distance, like it covered 2/3 of its orbit, but it will only cover 1/3 of the orbit. And what about the Z? The time for one orbit of a Z is twice taken by Y. So it means if the time is greater, the distance will be shorter. So it means Z will cover the shortest distance. So that's why B will be the right answer. Is it clear? This one? Or should I repeat? Yes. Is
And
it
then
clear?
repeat how you found about y.
How we can find about y? Look, time for one orbit of y is 3 times the time taken for x. Means like
It's three
if,
times slower than x.
yeah, like 3 times, yeah, definitely. Like example, because x is those planets which are closer, they are moving much faster and cover in a short time. For example, say for x it is example 1 year, so for y it will be 3 years, and for z the time for a one orbit of a z is twice, so z will be like 6 years. If you take this as an example, so if I say what is the position of x, x will be one. What is the position of x after 1 year? So one x will be here. What is the position after of y after 1 year? Because one orbit is for a y, one orbit is like 3 years. So this will be after 1 year, this will be 2 years, and 3 years it will be here. So after 1 year, y will be here. And for z, after 1 year, because it's like 6 years is the total duration. So this will be 3 years, this will be 6 years, this will be 4.5, this will be 1.5. So Z will be somewhat here. Is it clear? The
Yes.
position. So you divide the orbit into different intervals. You can, like comparison is there. If X, we can take any random values. Like if X is taking example 2 years, so Y, the orbital time of a y is 3 times. So it means y will take 6 years. And z will take how many years? It is twice of y, so z will take 12 years. And if the question is starting from the initial arrangement, the position of a planet X after 1. So it means after 2 years, what is the position of X? It will be same. After 2 years, what is the position of the Y? Because if Y is taking 6 years, so this will be the position of the Y after 3 years. So we want after 2 years, so after 2 years, the Y will be somewhat here in this region. And after 2 years, what will the position of the Z? So Z is taking 12 years, so this will be 6 years. This will be like 3 years, so 2 years will be somewhat here. So position of a Z will be here. So it will be X, Y, and Z. So B will be the right answer. Is it clear now?
Yes.
Question 31. The nearest star to the sun is about 4 light years away from the earth. A student make these statements about the star. So which statements are correct? Statement or statements are correct? Light from the star take about
B.
4 years to reach. Light from the sun takes 4 years to travel to the star and back. No, that's wrong. The star is outside our galaxy. That is also wrong. Why? Because our galaxy, the Milky Way galaxy, is about 100,000 light years. So means if this star is like only 4 light years away, it's within the Milky Way, not not outside our galaxy. That's why only one statement C is the right answer. In question 32, a planet orbits the sun with the orbital time. The average radius is, what is the average orbital speed? So average orbital speed is 2 pi r divided by t. So B will be the right answer. In question 33, the table 9.1 gives information about the 3 planets in our solar system. State the name of the planet. So we have Earth is given, which has a gravitational pull of 9.8. The Jupiter is there, gravitational pull 23. And this planet, the mass is given every distance from the sun. So means it is closer. So we have Mercury.
Venus.
Yeah, so we have Mercury, we have Venus, And the gravitational pull of the Venus is approximately like closer to that of Earth. So this gives an idea that this planet is a Venus. Why we did not select Mercury? Because the gravitational pull of a Mercury is very small. Like, and same thing, the distance will be very small. It's a comparable distance with Earth, and the mass is also. Describe a relationship in a table between the mass and the gravitational field strength. So what is the relation? If the mass of the planet increases, the gravitational pull will also increase. But we don't say they are directly proportional. Why we cannot say directly proportional? Because if two quantities are directly proportional, when we divide like mass with the gravity, we should get a constant answer. Like this mass divided by gravity, this mass divided by gravity, this mass divided by gravity, we should get a constant answer. But we will not get a constant answer. So we cannot say they are directly proportional, but we can say that when the mass of the planet increase, the gravitational field strength will also increase. So planet with a greater mass is having a greater gravitation. Explain why the distance from a sun is average value. Because these planets, their orbits are not circular, the orbits are elliptical. So planets have elliptical orbit. That's why we take the average distance, because some places they are closer, some place it is closer, some places it's further. Show that the average orbital speed of the Earth is about 30 kilometer per second. So we have the distance 1.49 exponent 6, and we have 365.2 days. So V is equals to 2 pi R divided by T. 2 into pi 3.14 into the distance, which is 1.49, 149.6, and then exponent 6 is there. So don't forget to write 10, because it's written 10 power 6. So you have to add 10 power 6 from the table. And divided by time, you need, it is written 365.2 days. You have to convert into hours, multiply by 24. So that will be in hour. Then to convert into minutes, multiplied by 60, then multiplied by 60. So when you multiply, it will be about 29.9 kilometer per second. That's the average orbital speed of the Earth. Question 34. The Milky Way is one of many billion galaxies. Each galaxy contains many billions of stable stars. Stable stars transfer energy into space by emitting electromagnetic radiation from the surface. Describe what happened in the core of a stable star to release energy and that eventually transfer into the space. So what actually happened in the stable star? So the nuclear fusion happen or occur. The lighter hydrogen nuclei fuse together and form helium. So the nuclear fusion happen or occur. In which the lighter nuclei of hydrogen fuse to form heavy nucleus of helium and release energy. On the Earth, the light from a distant galaxy is observed and analyzed by the astronomers. This information is used to determine the speed at which the galaxy is moving. How the observed light is different from what is emitted. So the galaxy, like example, say a galaxy is emitting out a light with a wavelength of say 470 nanometer. But because this galaxy is moving away, so as a result, what will happen? We'll have a redshift. So on the Earth, when we are observing this light on the Earth, it won't be same as 470. On Earth, it will might be 478 nanometer. So there will be a change in the wavelength, increase in wavelength from the distant galaxy, which shows that this galaxy is moving away. Or we'll observe a longer wavelength from the galaxy, or the wavelength shifted towards the red end. It's not like wavelength emitted out is different. It's what we receive will change. So the observed wavelength will be longer than the emitted, which shows the galaxy is moving away, or Doppler shift happen. State the quantity used to determine the speed. So if you want to determine the speed, what we use a redshift. So redshift is used to determine the speed of the galaxies. The Hubble constant, which is reciprocal of the age of the universe, calculate the distance from the Earth moving away with the speed. So we have the speed, we have the Hubble's constant, V is equals to h naught d. So V is the speed of the galaxy, 1.3 into 10 to the power 7. Hubble's constant is 2.2 into 10 to the power minus 18, and d we need. So this will go there in division. So it will be 1.3 into 10 to the power 7 divided by 2.2 into 10 to the power minus 18. This will give us the speed of the galaxy, distance of the galaxy, which is 5.9 exponent 24 meters. You can also convert into light years. Like use 1.1 light year is equals to 9.5 into 10 to the power 15 meters. So you can just, if you want to, they ask, then convert. Otherwise, no need to convert. Estimate the age of the universe. So h, like 1 over h naught, the age of the universe is reciprocal of the Hubble's constant. So 1 divided by 2.2 into 10 to the power minus 18. But when you divide, this will give answer in seconds, because this is second inverse. So this will be 4.5 into 10 to the power second. But here the answer is given in years. So you have to convert the second into years. So how to convert the second into years? First, second into minutes, we divided by like this is second. We want to convert into minutes, so we divided by 60. Then minutes we want to convert into hours, we divided by 60 again, or 24, sorry. And then hours we have to convert into like one day, 1 year, or 365 days. So this will give us the answer in years, which is approximately, because it's 14 billion years, so it will be 1.4, or 14 into 10 to the power 9 years. So you have to convert the second here into years. Is it clear? So second to minutes, we divided by 60. Minutes into hours, we divided by 24. And hours into years, we divided by 365. Is it clear, this one?
Yes, sir.
Okay. Complete the sentences about the life cycle of the star. Protostar is formed. So how the protostar is formed? So protostar is formed
Interstellar cloud.
interstellar cloud. And protostar become a stable star when what will happen? The gravitational force balances with a radiation pressure or outward force due to a temperature. So protostar is formed from interstellar cloud. And when the radiation pressure or a gravitational force is balanced with the radiation pressure, is the invert. Initial fuel used to produce a nuclear reaction in the star is, so it started with the hydrogen. Stars that are approximately same size of sun become a red giant, which is then form a planetary nebula. So it will form a planetary nebula and eventually a white dwarf at the center. Then the last is state what is represented in space physics by H naught. So this is called a Hubble's constant. Write down an equation which defines H naught in terms of speed.
V
And
is equal to Hubble constant multiplied by distance d.
yeah. So you can say V is equals to Hubble's constant times the distance. Numerical value is 2.2. State the unit, so it is second inverse. And use this to
Kilometer per second.
no, this is second inverse only. The unit of the Hubble constant is second inverse, this value. And then use
Okay,
this to
sir.
determine the age of the universe in second. So it is the age of the universe is reciprocal of the Hubble's constant. So 1 over 2.2 into 10 to the power minus 18. Hubble constant is the unit of the Hubble's constant is second inverse. Then state when cosmic microwave background radiation form and when detect and where we detect it from. So the
At the
cosmic,
start of the Big Bang.
yeah, shortly after the universe form or shortly after the Big Bang, and it is detected from all points in the space. So it is produces shortly after the Big Bang. And it is detected all around the space.
We can say it was detected from the edge of space.
No, not edge of the space. It's all around, like we observe. Not only the edge, it's all around we observe. So all points in the space is a right thing rather than saying edge only. Okay. So this was the exercise related to the stars in the solar system.